So good afternoon, everyone. Welcome to our webinar today. My name is Ng Siu Chun, and I'm the GoodWe Technical Sales Manager for Malaysia. I will be the moderator for the session today and would like to thank everyone for taking time off your busy schedule to hear us out. We really appreciate that, and we hope you will find our sharing today useful. The topic today is High Performance Utility Solution for Optimal LCOE, a short form for levelized cost of energy. And we are very honored to have our three distinguished gentlemen who are experts in their own field to join us today. Mr. Rishab Shrestha from WoodMac, Mr. Andrew Zhang from JA Solar, who will join us later, and Mr. Ned Ge from GoodWe Solar Academy. They will be sharing their insights and knowledge on the energy landscape in the region, as well as how the latest technology solutions could assist to lower the solar PV levelized cost of electricity, especially for the large-scale solar project. Without further ado, we will start off with free presentation by each of our guest speakers, followed by a roundtable discussion. Should you have any questions for our speaker, please type it out in the Q&A tab, and we will try to address it during the roundtable discussion. At the end of the session, there will be a lucky draw session sponsored by GoodWe. 3 lucky participants will be chosen from our participants today and will stand a chance to win an Amazon e-card worth $50 US. Therefore, please make sure you stay with us till the end of the webinar. Without further ado, I would like to welcome our first speaker of the day, Mr. Rishab Shrestha from WoodMac aboard to share us more about Malaysia's solar outlook and its sustainable growth. Just a brief introduction of Rishab. Rishab is a senior analyst focused on Asia-Pacific power markets with a particular interest in renewable market dynamics. His work includes power modeling and forecasting project economics of various generation technologies. He also leads the solar market research for the region. Before joining WoodMac, Rishab worked as a solar market analyst at GTM Research and MEC Consulting. And he helped the company kickstart its solar research product offering. He also has experience working with clean tech startups in the UK and India. I will now pass the floor to you, Rishab, please.
Thank you, Siu Chun. Let me share my screen. Are you able to see my screen? Hello?
Yes, we can see your screen, Rishab.
Great.
Please go ahead.
Okay.
Yeah.
Good afternoon, everyone, and thank you for giving your time and spending this part of afternoon with us.
Sorry, Rishab.
Yeah.
Maybe you would like to maximize your screen because you are on a presenting mode where we can see your second slide.
Okay. Let's see how I can do that. I swap.
Swap the settings. Yeah.
Is this good?
It's still the same from my side. Yeah, now it's good. Okay.
Okay. Great. So today I want to talk about Malaysia's solar outlook. And I've titled it A March Towards Sustainable Growth because that is kind of the growth trajectory that we're seeing in Malaysia. It's an exciting time in solar industry across the world, but more particularly in Southeast Asia. So let me dive into that. But before that, very quick introduction about WoodMac. We provide market intelligence for natural resources across the world. And I am part of Power and Renewables team, where we have over 100 analysts looking at wind, solar, energy storage, grid edge. I'm based out of Singapore, and we have offices across China, Australia, and many parts providing that market intelligence. We track projects, look at cost economics, look at market shares. So if you want any more information, please go to woodmac.com for more information. I myself have been looking at solar renewable markets for over 5 years, more focus on power markets. So today, let's focus on Malaysia's market. So here, I think it's helpful to see how the Asia Pacific global market is shaping before we dive directly into Malaysia. And as we can see here, we show the annual solar installations for Asia Pacific across the next 10-year horizon. And what you can see here is a very strong growth of 58% from close to about 83 gigawatts additions last year to about 131 gigawatt in the 2030s. And of course, China, like in many other renewables market, accounts for significant share. But then you look at the other countries, they are also expanding and growing. And you look at Southeast Asia, there's quite a few growth in that country. But if we particularly look at 2021, 2020 per se, there's a bit of decline, and that's because of subsidies that are being retracted, particularly in Vietnam and China, and moving towards auctions. But despite those challenges, what we see is countries announcing more ambitious climate targets or revising their targets, including Malaysia, and that's delivering the growth. And so it's a very hot and attractive market to be in. So let's zoom down on Malaysia more specifically. Here we're showing Malaysia's annual solar outlook for various different market segments, including utility scale, commercial and industrial, and residential, which are generally less than 20 kilowatt size. As you can see, historically, Malaysia's has been a very small market in terms of annual installation, with less than 200 megawatts installed from 2015 to 17. But then with policy, it has been ramping up quite sustainably and sort of that exponential curve. And so from 2020 to 2023, it more than doubles from over 600 megawatts to 1.4 gigawatt. And that's a very strong growth. And from that onwards, we see a more stable and a sustainable growth. And what other thing is that the majority of the market is dominated by large scale solar, utility scale, which is the dominating factor. And these can be, say, 30 megawatts to 100 megawatts or so generally in Malaysia, but I'll go down into the project specific breakdown later. But we can also see that C&I, or commercial and industrial sector, is a significant chunk, followed by least the residential. So talking about drivers, what happened was when there was a large scale solar auction announced, that kickstarted the large scale solar industry and is continuing to provide that growth. On the same time, we had the feed-in tariffs, net energy metering 1, 2.0, 3.0 now, that is helping drive the C&I and residential sector. And as I'll talk about more details, Malaysia has a clear renewable energy target where focus is given for solar, and that's also driving that growth. But there's also challenges, and one key challenges is the execution risks. Over in the history, there has been, because the market was nascent, there has been challenges delivering the projects in time, getting the required permits and delays. But as the local industry is maturing, those are being increasingly addressed. But with coronavirus, there is more logistical challenges and delays to come. But ST Malaysia has announced that this coronavirus is a force majeure event, and hence those delays will not have as material impact on the financials of EPCCs and developers as if it wasn't. The other increasing thing is also about profitability. Right? With more maturity, with larger market size, there's increasing attention, attraction from foreign investors, and it's being competitive, and the returns and prices are being pressured to push down. So that's a concern. A curtailment is not yet an issue because variable renewables are still low share, but as it grows, it can become an issue. So I want to focus firstly on the policy side, right? What is the Malaysia's renewable policy, or more specifically solar policy, and how do we expect that market to unfold? So we believe that currently Malaysia is nearly on track to meet its renewable target. And prior to COP21, prior to this year, they had a plan of 20% capacity mix by 2025. And as you know, these climate ambitions are growing. So with the COP21 this September, they revised their target to 31%. And this is a positive for renewables, also for solar, but not necessarily as much as you think, because there's also an inclusion of large hydro within this target. But nonetheless, this 31% target means that there's at least an additional 1 gigawatt needed for the project of 2025. And we see that being realized by large-scale auctions, continuation of that, as well as net energy metering. So let's focus on Peninsular Malaysia more specifically, which you can look at the middle chart. Of the 31% capacity mix target, 26% of that target will be met by Peninsular Malaysia. And Peninsular Malaysia is the largest demand center, accounting for about 76% of power demand. So it is a big market. And so here you can see that just above 4 gigawatts of renewables have been installed till date, with solar accounting for about 1.4. And by 2025, that 26% means that there needs to be around 8.5 gigawatts. And so here, what we see is the solar gaining more than 50% share of that market and very close to meeting that target. And so we see that the regular policy and the auctions contribute to helping assist that meet that target. But I think the real prize for Malaysia is really in the long term, when we expect, as economics grow quite high, with the 40% renewable energy mix target by 2035, we expect that solar will far exceed what the government is intended to plan. And so let's look at what are the evaluate the drivers there. Renewable targets, they're being increasingly ambitious, and that's a very positive. Secondly, we have among the Southeast Asia, one of the most stable policy. It's regularly condensed, and it's also evolving to take into account that industry is maturing. And there are also multiple routes to market, but not all the routes to market has been prioritized or enabled yet. Auctions, net metering, self-consumptions there, that's positive. But there are restrictions and volumes on capacity quota. We see that there is more interest in demand and supply, but government quotas on auction volume limits that. And secondly, there's also a penetration limit that the government is thinking of 24% of peak demand. While this is good to sort of protect the curtailment and have a stable growth, we think this will need to be relaxed. And with the introduction of energy storage and proper optimization, this relaxation will help increase that bigger growth. So how should that longer term growth look like, right? Malaysia has a lot of routes to market. It had feed-in tariff, it had auctions, which gradually grew. So it allowed people to become more mature and sustainably bid to the market. In the net energy metering market also, it's been having more, it's pushing industry to be more competitive. But if we really want to go to a higher renewable share, you need to have another route to market, such as corporate PPAs that allows offsite PPA. And this is part of the plan of the Malaysian electric supply industry 2.0, where they are contemplating to have merchant projects that can dispatch without PPA with NEDA, and they're planning to introduce retail competitions. And so in this the Malaysia's challenge is to how to incorporate hybrid renewables, have firm renewables so that at higher penetration, the grid is functioning properly, and as well as how can they slowly remove the quota and let the market determine how much capacity that's going there. So those will be crucial as a step further in future. Of course, there's various incentives such as tax allowances and tax exemptions and financing schemes that have been extremely supportive of the industry. So as we mentioned, how large-scale solar is the largest market there. And the reason for that is policy. Stable policy has attracted global and domestic investors and have made economics very attractive. There's been 4 auctions till date. And if you look at the left side of the slide, you can see that each of those auctions were 500, and the last Mentari 4th auction is 1,000 megawatt. And as you can see, it was a very well-crafted policy because 1.3 gigawatt in the first was subscribed just for 500, and that has been growing so much. But at the same time, the cost has been declining quite significantly, and more significantly in the third auction, where there was more than 25% decline in price. On average, in every bid auctions, the price has been declining by 22%. But as you can see here, the third to fourth auction, there's not as much deep price, and those are to do with project limitations and ownerships. So now what's happening in Malaysia is now the lowest cost is as competitive as coal. Coal is around low 40s dollar per megawatt hour for LCOE, and solar is also reaching there. The avoided cost is around $55, so the average cost of solar is cheaper than that. So that's very positive for Malaysia's renewable energy ambition. But the challenge is, as you can see here, right, the part of the cost decline was there's more partnership with other international investors, and those had lower, cheaper financing capital, and that also contributed to the cost decline. But with the fourth auction, it only allowed local 100% owned sort of companies to participate, and that to a certain extent subdued the price decline. And Malaysia needs to carefully optimize how do you handle industry and support local economic growth. So here I wanted to look at what is the current status of solar projects. And as we can see here that there's about 2.3 gigawatts of projects that's awarded. We have 1.4 gigawatts of operational project. And up until third auctions, there's significant, over half of that is connected, and there's still some progressing, quite significant chunk progressing. If you look at the progress rate, we see that the ones that are sort of on the borderline south here are mostly being connected, and there are quite a still substantial pipelines that are still remaining around the north. Also want to point out that the more northern you go in Peninsular, the higher the solar radiation is and the cost is there. So now on to what sort of project sizes are there, right? Like previously, there was fairly smaller size, less than 50 megawatt projects that are participating. But in the third auction, the capacity limit for auction was increased to 100 megawatt per bidder. And that sort of gave the auction winning to a lot of 100 megawatt projects and low project size. But for government in intention to increase more participant, limited to 50 megawatt on the fourth auction, and there is mostly 50 megawatt projects and less. So overall, we have 5 to 30 megawatt project size making the largest, and because of third auctions and the 50 megawatt size on the fourth auction, the 50 to 100 megawatt comes second. So that's the quick wrap up of utility scale. Now, I also want to touch upon the rooftop market where it is getting a lot of traction. We have NEM 3.0 or net energy metering, which has some capacity limits and lower compensation for commercial and industrial, but is being extremely attractive in the industry. It has already finished the quota, and although it is meant, that quota of 300 megawatt is meant for 2023. So just a brief description of that program. There's 3 programs there. One is residential, one is governmental, and one is CNI called NOVA. And those residential and government has 100 megawatt quota each, and then the CNI has 300 megawatt. As I mentioned previously, the timeline or the quota is meant to be from early 2021 to 2023. And in terms of economics, the attractive part is for NEM, the residential and government, where there's 1-to-1 export compensation, meaning that when you use the solar power for your own consumption, you're paying the price for the solar, but when you export it to the grid, you're paying the retail tariff. And retail tariff, to give you a sense, is around $115 per megawatt hour. But whereas in the NOVA program for CNI, you're exporting it to a system marginal price. And this is sort of the wholesale energy power market where the cost is much smaller or lesser than the retail tariff. For a NEM single, the capacity limits are up to 10 kilowatts. For government, it's 1 megawatt. And in NOVA, it depends, but could be to 5 megawatts. In terms of the credit term, it's quite attractive till 10 years. And after that, they could potentially sign another PPA with off-taker, or there could be other avoided cost metrics. And there's also an interesting energy bank period for 12 months and less attractive for CNI, but still economically makes sense. So here on the right side, what I wanted to show was the status of the program. Of the 100 megawatt capacity for this, we have 87 and 84 gigawatt left. So there's still time and quota left, and there's some gradual sustainable growth. But what is most interesting and have taken off is this NOVA CNI capacity market, where of that 300, that's already used up, and 162 megawatt has been approved. So more will be quite less. And this is despite the fact that they are being exported at system marginal price and there is a capacity limit. So this shows that there's a lot of interest in CNI, and if there is a market mechanism to allow or to capitalize that investment, that growth can happen. So here I want to give everyone a thought about how that future could look like. What can this next sustainable driver be? And I think corporate PPAs within this region could be quite interesting. Here, what we're showing is what is the cost of renewable LCOE and the retail power price tariffs. So if we look at Asia Pacific, solar specifically was more expensive than retail tariffs by quite significantly in the 2015. But today, in Southeast Asia and also in Malaysia, it's already competitive. And solar provides about 12%, 15% discount against retail tariff of $115 per megawatt hour. So as we go over to 2025, when those quotas, if the quotas were released, or even for large scale, if there was offsite PPAs that are allowed, the economics are very compelling. And on top of that, we estimate that retail prices will rise 11% over the decade, and that will make economics more attractive. So with these kind of policy mechanisms, we think that Malaysia can be very attractive. So to summarize, a very positive large-scale utility scale outlook for Malaysia. Secondly, net energy metering, despite some of the curtailment or despite some of the capacity limit and lower compensation, is gaining momentum specifically in CNI. And lastly, corporate PPAs can be a growth driver for the next longer term growth. So with that, I'll pass on back to Neng Siu.
Thank you, Rishab, for your very enlightening presentation, giving us some insight into how to sustain the growth of the solar PV industry in the region. So coming up next would be our guest speaker, Ned Ge from GoodWe Solar Academy. A brief introduction about Ned. Ned is the design engineer for the large-scale solar power plant solutions and has a lot of experience in terms of system design, project commissioning, and operation and maintenance. He has been involved in various major projects in China and is also now responsible for the new product development as well as project development in Malaysia. Let us hear from Ned firsthand how the GoodWe large-scale solar solutions could assist to optimize the LCOE of the solar PV farm. I will now pass the stage to Ned. Ned, please.
Hello, everyone. I'm Ned, Solution Engineer of GoodWe Solar Academy. And I have one of our application engineers, Craig, with me as well. He's going to help me on the questions at the end you may have for us. So let's get started. Here's the topic we are going to discuss today. As an inverter manufacturer, what we are doing to help our client to achieve a better LCOE, focusing on lower the system cost, more solutions for lower your maintain cost and more yield. First of all, briefly introduce you our company, a global leading inverter manufacturer. Top 4 3-phase string inverter globally in 2018, top brand for 5 consecutive years in Australia by EUPD research. GoodWe also as only one solar inverter manufacturer to win the QV Rainland or Quality Matters Award for 5 consecutive years. Just deliver the information that GoodWe will provide you a stable and reliable quality product with more yield, and also bring you the lowest operation and the maintenance cost. Next slide. Now we have products and solutions like below. Today we are going to share our 1500 watt string inverter, GoodWe virtual central string solution, GoodWe container type station, and our IVDiagnose from the monitoring solution to help you lower the LCOE. First, let's take a look at our 1500 watt system inverters and features. Inverter constitutes hardly 3 to 4% of the project cost. The inverter is a peculiar item. It can make efficiency as good as 99% and can also make theoretical zeros. Now we have 182 module and 210 module on the market, and this is why we have 2 products here, and models GoodWe 250K-HT and GoodWe 250KN-HT. KN is special for 210 millimeter wafer module, and the model without N for other wafer size. Main difference is that the KN has 6 MPPTs, and each MPPT will have 3 strings, and each string for nominal current is about 20 ampere. And you can see the other technical parameters are almost same with GoodWe 250K-HT, including the efficiency. As far as we can see, 182 wafer has been widely used in utility scale power plant. Our inverters could be fully adapted to 182 modules. We can see the mainstream 182 millimeter manufacturers module current here, and even the short circuit current of panel is less than 15 ampere, while our inverter's nominal current supports 15 ampere and short circuit current for 20 ampere. And it has already been a mainstream combination for 182 modules and 250 kilowatt inverters. So we can see our inverter can fully adapt it to 182 millimeter modules. Next is since the launch of 210 wafers, choosing 182 or 210 panel has become a controversial topic in the PV market. The main feature of 210 millimeter module has larger current and the open circuit voltage is less. As an inverter manufacturer, GoodWe quickly responds to launch our compatible products for 210 modules. You can see the string current is 20 ampere with 3 strings design. Most clients may have the concern if they need an external fuse to prevent 2 strings current back to 1 string when 1 MPPT connect 3 strings situation. Well, the KN, we still use the non-fuse design to solve this problem. It equips intelligent DC switch, which can automatically trip the DC switch when overcurrent failure. This DC switch can also receive the trip signal from the inverter DSP to shut down the DC circuit when emergency. So we can see our new model perfectly match 210 millimeter module. Next slide is about the Y branch connector. We noticed that some projects are using this Y branch design to lower DC cable investment. The parallel connection is accomplished by joining the positive of 2 strings together as well as negatives of each string together. Then the combined current transported by a 6 millimeter square DC cable to our inverter. At this scenario, the combined current can reach more than 25 ampere. Note that the 2 models can still support this large current if each MPPT only connect 1 string, but the string level monitoring will be disabled in this situation, while MPPT level monitoring still exists. Next is about the high temperature adaptability. As we all know, extreme high ambient temperature provides negative impacts on the PV module and the performance of inverter. And GoodWe focus on the thermal design to have inverter with excellent heat dissipation performance. So we have competitive derating temperature curve. 145 Celsius ambient, we have 90% rated output to gain higher yield. Next is biggest confusion for solar designers, developers is whether to go for a string inverter or central inverter. In case of rooftop or commercial and industrial systems is simply and clear. But when it comes to large solar plants, it becomes a difficult decision for designers. Let's take a dig into the comparison on a 100 megawatt project. Firstly, central inverter needs an external combiner box, which can cause failure rate more than 5% over the lifetime. If fuse melted, you need to find it and replace it. That may take a lot of work. String inverters won't need the combiners. Besides, we can always have 1 or 2 spares depending on the capacity in case of string inverters. We can change them when needed. The redundancy can improve and the downtime will be less. So considering the multiple MPPT feature, recovery time, and the generation, we assume a string may have 1 to 3% power gain compared to central over lifetime. Objectively, both strings and the central have pros and cons. String has multiple MPPT feature to reduce the impact on your production due to shading or defects of your PV module. Another factor string inverter solving is mismatch loss, when PV module degradation. And although it's a very marginally different of 0.6 to 0.8 as the years increase between year 1 and 25. As you can understand, the degradation of modules increases. So the defects are increased and will reduce the expectancy of your plant. So the string inverter allows the maximum production for any degradation that is potentially happening. Other advantages are longer operation hours due to the lower starting up voltage and easy to install and better system visibility. But still has disadvantages are high O&M for distributed locations of inverter and longer AC conductors. But with string inverter flexible design in large projects, we have solutions to make up the disadvantages. Now we can see string inverters are easy to install, less investment, higher yield, and safer. But also with the emergence of new tracker technologies and bifacial panels used in the power plant, the string inverter will have added advantages. Keep in mind that the string inverter benefits and the costing is also coming down. We believe the trend in inverter market will be more string inverter be used and the shift is happening. Next, we are going to share some string solutions, products, and O&M tools. First, a list of the negatives when string compared to central inverters. Is our centralized string system. Actually, it is not new for developers, but now we are talking centralized systems using string inverter skids or containers, which we call virtual central, is showing on this picture. This one is a skid version, and now we are also developing a containerized version. Back to the solution, you are putting those inverters close to the point of interconnection. The lower O&M can be achieved by using virtual central. This longer DC cable design will slightly raise the cost of the system, but what we gain more from this is an easier O&M plan on large size, and you are saving installation later as well. This has been done in very large applications right now in China, Qinghai province. We can install the inverter on an individual skid and build the frame close to the transformer path. Through this, some inverters troubleshooting and firmware used to be updated performed remotely can reduce the downtime. By the way, our inverter can remotely update firmware through PLC or RS485. Besides, virtual central solution compared to central inverter will have lower cost for they do not include the DC combiner box. And remember too that 1500 volt DC is the top of the low voltage scope. Combiners may also have a breakdown risk. So we are balancing the system cost by using this solution to lower your LCOE. Next product is the turnkey system, medium voltage switch gear, and this product we are releasing to market is a MV power station, offers the highest power density in a plug-and-play design, maximum capacity up to 6,800 kVA. It is suitable for global use. This turnkey system generally has main components including rain main unit, transformer, low voltage switchgear, backstack, and connection cables and auxiliary circuits. The pre-configured 20-foot skid are pre-designed, pre-tested, and assembled at the factory and shipped in one piece, so it is simple to drop in places and connect cables. All electrical equipment installed in one frame to minimize side works and maximize pre-testing and safety. Open air design, that means no exposed, that also brings the no exposed live paths. All live paths are covered to ensure safety against electrical shock. All electrical equipment conforms to Malaysia local regulations. As you can see from our data sheet, the maximum power rating, now we can reach the 6,800 kVA. Low voltage side can support max 30 pieces of MCCB to connect with. So we also heard voice from clients that they may have corner array which only has less than 3 megawatt. We can also customize the power rating to meet your requirement. Next is our plant monitoring system. It's a local management solution used in plant, which allows control over individual devices. It has functions like for data customization, data analysis, remote control, automatic reporting, and OM management. Designed for field technicians and control room operators. It helps to improve your O&M efficiency. The last is our IVDiagnose. IV Curve is a tool that we are supplying as a software, so there is no additional hardware required. If you've got GoodWe inverter and data logger, as long as these products are installed on your site and you are transmitting that data to our monitoring platform, then we can run IV function on your site. We can also enable our IV function on a third-party platform. By using our IV curve to evaluate the cost saving that you are able to achieve, IV is basically a measurement of how healthy your screens are, and we are evaluated this on many projects. It enables O&M teams to scan a 100 megawatt power plant in less than 20 minutes. That used to may take manpower around 1 month to carry out the IV diagnostic for the site. Actually, it really helps on maximizing the revenue of your PV plant, also lower your operation and maintenance cost. Now I'd like to thank you for your time, and I'm gonna hand it back to my colleague Sue.
Thank you, Ned, for the informative presentation. I'm sure that this have given all our participants some food of thought and also alternative solutions to ponder upon. As mentioned by Ned in his presentation, GoodWe offers a turnkey MV station solutions with excellent thermal performance that is compatible to both 182 mm and 210 mm PV module, which will definitely be able to optimize the levelized cost of electricity further. After hearing from our inverter expert, I'm sure all of you are eager to hear what our next speaker can share from the perspective of the module manufacturer. Without wasting any time, I would like to welcome Andrew from JA Solar on board to share with us the latest technical innovation in JA Deep Blue series. A brief introduction of Andrew. Andrew has 9 years of working experience in the solar industry. He joined JA in 2016 and is the technical sales manager for the APAC market. His main responsibility is to provide technical support as well as business development in the APAC region. The floor is yours, Andrew, please. Andrew, yeah.
Hello, everyone. Sorry. Can everyone see my screen?
Andrew, you are muted. Yeah.
Can everyone see my screen now?
Yes,
hello?
Yes, we can see your screen. Yeah.
Okay. So hello, everyone. My name is Andrew from JA Solar. So I'm from the JA Asia Pacific sales team, and thank you for the opportunity providing by GoodWe. And actually, I would like to brief some key points regarding the JA Solar Deep Blue 3.0. product with infinity future benefits. Actually, the main focus of this webinar is for give you a better understanding about the GE key products, which are primarily designed for solar farm from a technical perspective. And so this webinar, I would like to introduce your 4 parts. And the first part is briefly introducing about the GE Solar and GE Solar Deep Blue 3.0. And our target is to let client understand the changes that the PV module are undergoing. So we will analyze how GE launched GE Deep Blue 3.0 from a practical point of view. And the second part, so we will briefly introduce about the details about highlights of GE Deep Blue 3.0 and the value analysis of Deep Blue 3.0 from the perspective of BOS savings, LCOE benefits, and also the actual site survey data. So as GE launched Deep Blue 3.0 Pro during SNEC exhibition, and so in the third part, I will introduce some new product regarding the highlight of Deep Blue 3.0 Pro, which will be launched within this year. And in the last part, I would like to present some future products in the year 2022 to 2023 and the GE technical reserve and ideas for the vision of future. So firstly, let me introduce about the GE Solar. And the GE Solar is the top 3 solar module manufacturer suppliers, which is set up since 2005 May, and with around 11 world market share achieving by GE advanced leading technology and the vertical business model. And in 2020, so our revenue is around $3.75 billion, which is contributed by 33,000 value customer and 22,000 employees. So currently, GE has owned more than 40 gigawatt module manufacturing capacity based on the 12 GE global manufacturers. So here are some project reference, and as GE is a rich sales revenue and customer confidence, so GE has supplied lots of solar projects accompanying with recent years global solar project rapid up. So the first one is for the 50 megawatt solar projects in Malaysia, in Kuta, and we also have the 17 megawatt in Australia. And this is the first trackers plus module project in Australia. And we also have the first bifacial PERC mono project plus tracker solar farm in Malaysia. And we also have the supply the largest solar farm in Philippines with capacity 132.5 megawatt. And besides the utility, so we also supply the module for the CNI projects. This is a project in Singapore, Marina Bay, and also the 3M in Singapore, Vivo City, Singapore, and also the Malaysia Rooftop in Kuala Lumpur, and also the Adidas factory in Vietnam, and also IKEA project in Thailand. So let's focusing on the first part regarding the design idea of the Blue 3.0. And firstly, we need to go back to the module technology development since 2009, as it will be good starting from the module power increment history. And the graphics show that the module wattage increment within the 10 years. And from this blue part between 2009 until 2012 is 2. So you could obtain the information that actually the module power increment is mainly contributed by the cell efficiency increasing annually and the increased technology, such as PERC mono, PERC product with mono, PERC selective emitter, and multi-bus bar. And between and actually 2 years ago, you can see that the module power is roughly around 290, and with the module efficiency 70%. And after 10 years, actually the module has achieved 400 plus wattage, with the module efficiency more than 21. And actually the biggest power changes are mainly started from the year 2020, because the low PPA incentive, example for Malaysia for LSS1, and the module supplier point of view. So GE has launched a couple of kinds of products for meeting the market request. So this is the details. So how the module power has been enhanced by different technology. First item is regarding the cell efficiency increment. So climbing up from 17% to 23% during 2009 to 2020. And this is mainly contributed by the PERC technology. And the PERC, the full name is Particular Emitter Rare Contact. And the cell efficiency compared with previous poly technology is significantly increased. And in the meanwhile, so advanced module encapsulation material has been used, like anti-reflection coating class, and also the secret extra softer ribbon and high transmittance EVA, and also some more shape like half cut, cell, multi-bus bar, and also there are new technology and the technology reserve like shingle, paving, hair density, and act. And besides, so the biggest change also happened in the wafer sizing. So the initially is only 125 millimeters. Now has during this couple of year development is changed from 125 millimeter to 156 millimeters, and then going to 166 millimeters. Then and right now is there are two treats. One is 182 millimeters, and another one is 210 millimeters. So from BOS cost of evaluation, so we have set up two graphics where BOS with module wattage and also BOS with module efficiency. Actually, from the left graphic, this graphic, we can see that based on the same power efficiency, of course, the larger module will with higher power input will significantly reduce the module BOS cost. But actually, you can see these 2 points, but BOS deduction effect become less. So when you keep enlarging wafer sizing, example for 182 millimeters 72 cells module with wattage 540, and also the 210 millimeters 60 cells with the wattage 590. Actually, their BOS savings is all similar. And from the right graphic, actually, we can see that actually the real BOS reduction is coming from the module efficiency increment. Actually, the main drivings of BOS reduction come from efficiency increment together with the module power increment. So actually, besides the module power means, module power wattage based on the single module, and also the module efficiencies. So we also need to consider that whether the module application from practically, and whether the module is the larger the better. Actually, we can see that over sizing of module doesn't contribute more BOS savings on system side, but bring more potential risks. And excessively increase the module power through bigger wafer size will be more and more valueless. So because you need also for bigger sizing of module, you need to consider about the mechanical load risk. Example for hurricane area. So the module will be suffer loss of the wind load, and also the transportation and the installation, because the larger of the module is the more difficult you need to hand over and the putting on the structure, especially at the project site. And also the structure loading capacity, because when you design for a larger size of module, you also need to develop a suitable structure for module installation. So apart from previous concern, actually I also evolve one small subject regarding the module VOC and ISC, and module open circuit current and open circuit voltage, and the module short circuit current, so which will be considered as a priority. Actually we know that power equals voltage times current, and high power means at a higher voltage or current. So example for 78 cells 182 millimeters module with half cut, and also the 1/3 cut 50 cells 210 millimeters module. Actually, you can see that it, and compare with 6 cells 210 millimeters module half cut. Actually, these two type of module belong to the high voltage but low current, well, the 60 cells 210 million module belong to low voltage but high current. So the low voltage current module like this one will be definitely add the string capacity and decrease the system cost. But there will be another impact from the large current on system and the module itself, which should be noted. So this is the simple summary for two typical kinds of product and the different wafer sizing. And you can see from this graphic that more busbar technology, of course, will driving the module power means, but more resistive loss will be involved if deploy more busbar. And this also lead higher CTM loss and module production costs. So, and in the meanwhile, so during the module operation period, so the high current also lead higher module internal resistance loss and boost up the module operation temperature, especially in Malaysian market. So normally the module temperature will be roughly around 50 centigrade. And if you're using large current module, so there will be around 7 to 10 centigrade higher compared with normal module. So the higher of the current will lead the potential issues such as hot spot or junction box burnout. So this is the value we have analysis under GE R&D Center. So we have set up the test bed for this comparison between 182 million module and the large current module. And the real data was collected based on the one intraday solar system operation. And actually you can see that the solar module temperature become higher if the module current is higher. And this leads significantly reduced loss and power generation loss. And according to the third-party report, compared with the larger current module, I mean, with the current IC equals 18.5 ampere. So actually the power generation of Deep Blue 3.0 is more than 1.5% higher. And of course, the LCOE will be significantly better. So this is one of the site survey data. So we have GE has cooperated with TUV conducted in China, TV North conducted in China for 1 year module operation in the actual outdoor. So actually it's at the National PV Examination Center, so in Yinchuan, the west of China. So actually according to the data record at project site, actually our power generation is about 1.7% higher than the large current module, and especially during high radius period, like 1 p.m., 2 p.m. So the average module operation temperature gap is roughly around 1.7 centigrade, and the maximum gap is around 5 centigrade. So this is a design. So why GE select 182 million module as a preferred. So the design principle for 182 is based on the suitable dimension with dimension 2.2 millimeters long and 1.1 millimeters width, and it's suitable dimension for easy handover, and also it has the proper electrical parameters with normally high voltage, low current, and also have the reasonable weight for easy handover. So for this kind of GE Deep Blue 2.0 product, actually we have awarded best result for simulation from TUV Ryan, so last year. So among all quality methods award. So okay, so sorry. So okay, so for part 2, so let's focusing on the technical highlight of Deep Blue 3.0. So actually so far Deep Blue 3.0 has shipment is more than 3 gigawatt, and actually our production capacity for 2021 is 30 gigawatt. And for GE product series, because we are designing the module and the different system and the market segments, so we have various kinds of the key products matching clients inquiry. So for utility, we have the 22 cells with Deep Blue 3.0 with the wattage 450, 545, and also have the 78 cells 600 and 595. And for CNI and residential, we have the besides the 72 cells, we also have the 54 cells with the wattage 400 for easily handover and installation and the rooftop. And here is the module configuration with 182 meter wafer. So we have the 3 kinds of products for different system configuration, and with half cut, and is wafer upgrading to 182, and it has a metro production facility, and is compatible with the existing production line, and also have the production year code. So this is the design ideas based on our Deep Blue 3.0. So we are aiming is we design this product adapter with existing system configuration, but high efficiency, more suitable parameters, and more installation capacity, and also lower BOS costs, but higher power generation. So for this product, we are using upgrade PERC technology. So with a better long spectrum response, and also higher low irradiance property. And the meanwhile is also have very low temperature core efficiency. And we also deploy with 11 busbar, half cut cell, and also have the reliability test under the third party. So besides, we also deploy with a gallium doping. So compared with previous boron doping, so far GE can guarantee less power degradation. Now is for single glass module, we can guarantee in the first year no more than 2% and 0.55% from year 2 to year 25. And for double glass, we guarantee 2% for first year and 0.45% from year 2 to year 30. So it has 11 busbar configuration, and with the round busbar for improved the module light absorb. Also, we have the reliability for the 11 busbar design and the signal ribbon for product operation stability. Besides, this product also designed for half cell, so for enhance their mechanical property. Also, it has lower LCT operation temperature. So example is J adapter with GoodWe, actually successful for GoodWe's premier MPP design, actually based on the 15 ampere limit. Actually, our Deep Blue 3.0 is adapted with GoodWe inverters. So this is analysis based on different sizing of the wafer. So also the BOS analysis actually for Deep Blue 3.0, it has very premier BOS savings. And besides, from installation capacity point of view, Deep Blue with 72 cells also achieved the highest installation capacity, but the lowest initial investment, and this will shorten your return of investment. And from system LCOE perspective, so we also analysis some sample projects. We're using GoodWe inverter and other industry inverter, and actually Deep Blue 3.0 configured with GoodWe inverters has very good performance compared with other inverter suppliers. This is based on from the Rooftop project, and this is the details compared with based on different sizing of the module. So we're using GoodWe inverter. So what is the BOS deduction? So based on the utility solar farm analysis, so we are select 15 megawatt project as a reference. So Deep Blue 3.0 together with GoodWe inverter also have very best performance. So this is also the BOS cost comparison based on the 166 millimeters module and the 182 millimeters module. So here's the summary for Deep Blue 2.0. So it has very good temperature core efficiency and also very good low light performance. And their sizing is suitable for different kinds of the rooftop and the utility projects. And it has very low degradation guarantee and a reasonable weight. Okay, so the subpart is about Deep Blue Pro, which we are new launch during SNEC. And we are seeking that the higher efficiency and higher power means for the module for achieving for 60 wattage more for next 2 years. And we are deployed with the gapless connection for increasing the module efficiency. And we also passed the reliability test, and the test result is very good compared with industry acceptance criteria. And this is the best LCOE analysis. So based on the GE Deep Blue Pro, so they have very good benefits. And this is the LCOE analysis. So GE Deep Blue will significantly reduce 3 to 4% LCOE ratio, so compared with 166 and also Deep Blue 2.0. So some vision about the future. So actually, GE has many technical reserve for the future technology. So we are mass production for the P-type module, P-type plug, and actually GE has already reserved technology for N-type plug, also HJT technology. And this is our product series vision of the future based on different year and quarter. So actually, our product's advantage is we are hoping that our product is high power win and efficiency and excellent reliability. And besides, we are complete the production range. So this is some vision of the solar. So from Bloomberg and Arena. So we are hoping that the solar capacity and the installation capacity will be put up in the couple of years. And for J, so we also have the zero net actions like green technology, green supply chain, green electricity supply and usage, and also green manufacture and green office life. And so J has deployed the concept of green energy development for achieving carbon neutral target. Okay, thank you so much. My presentation is finished.
Thank you, Andrew, for the insightful sharing. It is indeed a very interesting analysis and comparison between the two schools of thoughts. I personally agree with Andrew that the next most important priority for sustainable industrial growth would be the module efficiency increment. We look forward to more technology innovation in the future from our fellow module partners. So coming up next would be the roundtable discussion and the Q&A session. I would like to invite all our guest speakers, Rishab, Andrew, and Ned, to join us again for this session. So I look at the clock, we are slightly behind our schedule. So without wasting any time, I will kickstart the session and I will go for the first question. So as Rishab mentioned in his slide earlier, the Minister of Malaysia Energy and Natural Resources Ministry, KETSA, announced that Malaysia is focusing on its generation plan with a target of 31% renewable energy in its installed capacity in 2025 and 40% in 2035. So my first question to you, Rishab, do we expect Malaysia to meet this target? And how significant role will solar play in helping achieving this target? Rishab.
So thanks for the question. And great presentation, everyone here. Learned quite a bit. So I think Malaysia is having a lot of good policies in terms of trying to meet that target. And the recent increase in the policy target from 20 to 31% is actually makes it more ambitious. And on top of that, including large hydro helps a bit. But what we see is that they're almost very close to meeting that target in 2025, but there's also risk of projects getting delayed, particularly because of coronavirus and other government priorities because of that. So almost meeting that target in 2020, or there might be a delay in a year or so in meeting that peninsular Malaysia as well as Malaysia target. But what Malaysia will definitely be achieving is overachieving its longer target as the industry kind of matures.
So thank you, Rishab. So a follow-up question for you, Rishab. You mentioned earlier that the market size need to be increased at least by 1 gigawatt. Can you be more specific on this? What would be the market size for rooftop solar and large-scale solar?
So what we're seeing is you have a 8.5 gigawatt of target for 2025 based on 31%, 26% for peninsular, and for peninsular Malaysia we have 1.5 gigawatt of 1.4 gigawatt of solar. So to meet that gap, we have about 2.5 gigawatts of those renewable projects that is committed, and the remainder one of close to 3 gigawatt remains to be addressed. And part of that will be hydro, but what government in their generation plan has said that is it will be around additional 1 gigawatt of project that will be needed for sure, definitely, to have this meet to achieve this target. So hope that answers your question.
Okay, thank you, Rishab. So Andrew, from your experience in the region, do you have anything to add on for the future solar outlook for Malaysia?
Actually, I totally agree with the comments from Rishab. Actually, we are seeing that in Malaysian market there are many incentive policies. So at this market for hitting this target of renewable energy. And actually, though maybe the policy currently is very limited, but we see that there are plenty of rooftop for solar project development, even not under NEM or whatever. So actually, some developer in Malaysia, they are even open like a private PPA and just a night metering for factory consumption. So I think it's a good end. But once there's any incentive policy where we launch, example, maybe NEM 3.0 whatever, actually the market will push up very soon. So actually for Malaysian market is belong to one of the very mature market in South Asia. And they have very mature EPC and developer, and they have, of course, they have very good evidence. So for solar development.
Okay, so since Andrew mentioned about NEM and Rishab also talked about NEM earlier in his slide, so we know recently we also see a very quick update on the NEM 3.0 NOVA quota, while a bit slower for the NEM Rakyat and NEM Government. So how positive is this NEM 3.0 for the solar market growth in Malaysia? Should we have more quota for the C&I segment since it's so quickly taken out? And yeah, maybe Rishab, you can enlighten us on what quota size, in your opinion, would be more reasonable. You are muted, Rishab.
Thanks for the question. So what I can say is there is a lot more demand than what government is estimating. Right? So there is the propensity and willingness to buy, and there's a lot of corporates who are interested in reducing their electricity cost, from food and beverage to multinational corporations. So there is that demand, but there is also need for a sustainable way to address that growth. Right? How can you improve your process of permitting? How can you improve process of grid integration of rooftop solar? And so what they've done is they've kind of based the target with 24% peak demand limit to help improve that. And what I think with knowledge sharing from other more developed countries who have reached higher penetration, they should be thinking about how to lift off this quota. But in terms of capacity size, I think, if 300 megawatt is being wrapped up in almost a few months, then I think at least a similar size, like if we are wanting for next 3 years, right, it could easily double, or if not more, around this till 2023 period. But there needs to be a consideration on how it's just not about solar, but what are the potential costs that will be added to system and that cost. And those are studies that are being done currently in Malaysia, and that needs to be accelerated. And once that has been done, then I think we can come up with a more sound answer of what is that capacity. But given that renewables penetration in the grid still remain low, I believe it can easily double, if not more.
Okay, thank you. Interesting. So besides the permitting issue, Andrew, from your experience, what is the other challenges for the CNI segment? And yeah.
Yeah, actually, thank you for this question. So I will say that I have the mutual agreement with Russia. Actually, is the first one is actually for this year, especially recent 3 to 4 years. So actually, the total cost of the solar system, including the panel prices going down significantly. So actually, this is maybe incentivized by the low PPA or lower, how to say, the requirement from the application point of view. And we all know that actually for the AEM 3.0, actually even the sizing is based on 500 megawatt more or less, actually, but it's right now very soon because actually, as I said, actually Malaysia is very mature market. So everybody know that how to calculate this financial model for the solar system. And from module supplier point of view, actually GE has provided various kinds of the key product for supporting like a CNI project. So actually example, so for 182 millimeters module, actually we have developed 3 kinds of key products and the different market segment. Example, we have the rooftop key product and also have the utility key product on the market requirement. And actually, I'm also very excited that now many customers in Malaysia are looking for bifacial module, so aiming for higher with space constraint. So because they are looking for high power generation, so not just calculation based on the costing. So this is what I see right now.
Okay. So Andrew, a follow-up question for you. Do you see the advantage of using bifacial panel for the large-scale solar project as well?
Yes, actually, according to my presentation, so so far for JA, we have supplied projects they developed with bifacial plus tracker project in Malaysia. And for large-scale solar farm, we're using bifacial module. So first of all, is client is expect 30 years back-to-back warranty, and they also expect a lower annual degradation, and also together with additional 10 to 20% year code. And in the meanwhile, they also save more land and shorten their ROI. Significantly, the LCOE will be deduct around 7 to 9% for using bifacial compared with monofacial.
Okay, and Ned, as from the perspective of GoodWe, Ned, do we have our solution to be compatible with all these bifacial modules?
Yes. First, thank you for your question. Well, bifacial modules produce solar power from both sides of the panel. That means as an inverter manufacturer, we need to utilize this energy gain and minimize the risk of a larger current. We are facing challenges like larger DC input current for inverter and how to protect system when short circuit comes with more power, and how to use this gain more efficiently. First of all, with bifacial gain, usually 10% to 15%. Our inverter's nominal current and short circuit current have enough redundancy to cover it. For example, for the JAD Blue 550 watt module, we can have nearly 30% redundancy short circuit rating for the rear side gain. Another thing is our MPPT feature. This can effectively minimize the mismatch between different bifacial panels and their rear gain. And this is a central inverter cannot serve. So when bifacial panels are used in your plant, a string inverter can help you maximize the backside gain. That's what we are offering.
Thank you, Ned. Yeah. Okay, thank you. Thank you very much for your answers. So I see there is a lot of questions from the floor. We are running out of time. I will try to pick a few one, and then for the rest of of that, we apologize that we have run out of time and could not answer everyone. So the first question is from Mr. Skip. So Mr. Skip asked that, what is your opinion on the TNB's strong arm influence over the solar installation guideline in Malaysia? So Rishab, maybe you have touched about it, but maybe you can explain more on that.
So I think, there are in Southeast Asia, there is different influences to that industry, right? And then TNB does have, say, a good understanding of retail side, how grid is operating. So they are in a position to say how should this be evolving. But at the same time, as part of a liberalization and in sort of improving retail markets, allowing on additional routes to market, it becomes a conflict of interest because revenues are being competed against them. So far, as we see that Malaysia is growing sustainably in quite positive way, and that has been a stable growth, I think that influence has been quite positive, right? And I think if even more growth is needed to be maintained, I think there is a need for being more open to competition, to being opening to more routes of market, to unlock a larger market scale.
Okay, and we have another interesting questions from an anonymous attendee. So maybe this is a question for you, Andrew, regarding the panel prices. What are the factors that causes the panel prices to fluctuate? As a service provider, the prices of panel actually increases since the COVID-19 pandemic. When you mention prices are lower, how do you mean by that? Andrew, maybe you would like to go over it.
Okay, this is a good question. I think everyone is asking right now. So actually, for this year, just a transparent for this COVID situation. Now, I think it's not very good, both in China and global. I will see that is. So the COVID situation is the factor that driving the shortage of the silicon raw material. As you know that, so GE is a vertical company for silicon ingot and tube module, but we have the same sourcing between solar module and the semiconductor industry. Semiconductor is used for the laptop chips, PCB panel. So this shortage is coming from, actually you also have heard some news around for the shortage of chips for mobile, right? Actually, it's the same source, which is called silicon. And this silicon is done in chemical industry and driving by some main players, which is not in solar industry. As this year, during April, May, actually, so maybe you know that last year, the module is slightly going down. But this year, April and May, because maybe the political policy, I cannot present during this webinar, but I will see that during April and May, the module price is increasing and it's much higher. It's because the silicon price is increased. And I would indicate one number. In March, the silicon cost is around 120 RMB per kilogram. And after May, the silicon cost is 220 RMB per kilogram. So this is driving maybe due to several factors, because most of the silicon production is in the west of China. And besides, China also need to hit the carbon neutral target by 2030 and 2040. 2030 is maximum, 2040 is zero. So they limited the polysilicon production. And this year, actually, every supplier is extending their production capacity. So this lead the standard shortage of the silicon supply in the whole industry. So when you check with every supplier, so maybe they will give you the same reason. And in the mobile, so there's another factor is the logistic. Actually, between China to any other country, the logistic cost is around 2 to 3 times higher than the cost in 2020. So actually, these 3 factors may lead the module price significantly higher during this period. And actually what we expect is in 2020. So when actually this is my hope is when the COVID is over and the supply chain is more it's not such dynamic, so the module price may still can be going down. So I have no idea whether I have replied this question, but I will see that we are seeking the rules.
Okay, Andrew. So another question from you. This is more technical one. Thank you for answering the sensitive question. So which one, I think the question would be, which parameter is more important when installing high voltage panel, for example, Deep Blue 3.0 and so on, voltage or ampere?
I hadn't seen the question. Can you repeat again?
Which parameter is more important when we choose to install the high wattage panel, so high performance panel like Deep Blue 3.0 and so on? Is the voltage more important or the ampere is more important? How does it look on the system design?
I think this is electrical point of view. I think GoodWe can also answer this question, but I reply at first. So first of all is regarding, because panel is the unit for power generation for DC power, right? And then GoodWe inverter need to convert into AC power. And first of all is when we launch a new product, we need to consider about our inverter partner, right? So whether they can compatible with whether our new product can be compatible with inverter suppliers configuration. So basically, so for solar system, it should be designed as a high voltage because the components need to make sure that during the power transmission from the panel cable side to inverter input side. So we need to make sure that the power loss is lower at the lower. So basically for the high voltage transmission line example for substation. So nobody is doing low voltage but high current because during the transportation, the current will make the loss, right? The formula is 2 current times a resistance. So the resistance is based on the cable but the current is based on your output. So basically for solar module, it should be designed for high voltage and low current for make sure that more DC can be injected into inverter.
Okay, I think that's all. We are running out of time. So maybe for the last questions, both Andrew and Rishab mentioned about corporate PPA. So is this something moving forward for Malaysian market? Maybe both of you can give us a word on that, final words on this topic.
So I think it's just getting started. Southeast Asia is still early in the growth phase. Economics is starting to make sense. Retail tariffs are expected to escalate. We have corporates that want to go green. So it's a very good drivers for growth. And we expect that to be growing as markets and policies allow it to happen. Yeah.
Okay, Andrew, on corporate PPA.
Hello.
Andrew, on corporate PPA, yeah. Final words on corporate PPA.
Yeah, actually, so I think corporate PPA has discussed for a long time, to be honest. So, and I think like metro market, there are, how to say, for metro market, so they have some study case. So like in Australia and the Europe market. And I'm hoping that there's any corporate PPA project being launched, to be honest. So I don't have any further comments.
Okay, thank you. That's all for our roundtable discussion today. So moving on, we are running out of time. So moving on would be our lucky draw. It would be, I'm sure this is the most exciting time for all our participants today. who will be the lucky ones today. So yeah, okay, congratulations to our 3 lucky draw winners, Yikai Chan, Vijaya Khan, and Wenhui Li. So my colleague will send the Amazon e-card to your email, register for the webinar latest by next week. So please stay tuned and check your email. So guys, that will be the end of our sharing session today. On behalf of GoodWe and our partners, thank you very much for joining us today. We hope you have enjoyed our webinar today and is able to take home some meaningful insights. Please don't forget to subscribe to our GoodWe Academy community. You can Google it up. So we have just set up this GoodWe community where you can have learn more information about our system solutions as well as participate in webinar. Coming up in the 20th of August, we have another session on the storage inverter as well. So please stay tuned and hope to see you soon. Have a nice weekend and take care, everyone. Stay healthy and stay safe. Goodbye.
Thank you. Bye.
Bye.
Thanks,
Bye.
everyone.
Bye. Thank you.
Bye.
Bye.